Hello, am I audible? Hello. Okay, so let's start the live session. Hello, everyone. Good evening. My name is Pankaj Kapdi, and I am an NPTEL PMRTA for this course, Basic Calculus. And today I will discuss some problems related to the differentiability of real valued functions and some properties like finding maximum minima of these functions using the derivative of functions. Okay, so let's start with our first problem. Okay, so this is our first problem here. You can see that we have been given a function. So this is our function for when x is non-zero, and at 0 the function value is 0, and we have to find out what is the derivative of the function at x equal to 0. Okay, so for that, okay, so let me just recall what is the definition of differentiability or derivative at a point. Okay, so given a function f from some subset, its domain is some subset of R, so this is a real world function, so the codomain is also R. And so okay, the function is given, and let's take some point inside the domain a belongs to a. So we said that f is differentiable at a point which is here we have fixed that at a or at x equal to a if the following limit exists. Okay, if the limit h going to 0, f of a plus h minus f of a divided by h, if this limit exists. Okay, and the derivative at, okay, so if this limit exists, the limit is called the derivative of f at a. So derivative of f at x equal to a is the limit. Okay, so here the limit exists, is the limit, this is limit, this limit. Okay, so a plus h minus f of a divided by h. Okay, so this limit is called the derivative of at derivative of f at a, and so this limit we denoted by f dash at a. Okay, so this is the limit. Okay, so in other words, we can also write it like this. So f prime at a is same as limit x going to a of this thing fx minus f of a divided by x minus a. Okay, so this is also the same thing. Okay, so in our problem, in the first problem, so the given function is defined like this. Okay, so what is our function? It is f of x is equal to x times mod x, right? So this is x times mod x sine of 1 over x. Okay, so when x is non-zero, and it is 0 if x is 0. Okay, and we have to find out if this function is differentiable at 0 or not, and if it is differentiable, to find the derivative. So actually in the problem it says that find the derivative of function at x equal to 0. So they have already assumed that the function is differentiable, but it's actually the same thing, because if the derivative exists, that means that it is differentiable at that point. Okay, so we have to find f prime of 0, which is by definition is limit h going to 0 f of 0 plus h, because we are finding the limit or derivative at 0. So this is f of 0 plus h minus f of 0 divided by h. Okay, now okay, so this is equal to h going to 0. Now we'll just apply the definition of the function. So f of 0 plus h is basically f of h, and by definition it is equal to h times mod h sine of 1 over h. So f of 0 is 0, so this is just divided by h, which is same as limit h going to 0. Okay, so you can see that these h we can cancel out. So we have mod of h into sine of 1 over h. Okay, now you can see that the this limit exists and it is equal to 0 both from left hand side and right hand side. This limit is equal to 0. Okay, so hence f prime of 0 is 0. Okay, so the function is differentiable and its derivative is equal to 0. So here the first option is correct. Okay, so now it's time to move to our next problem. Okay, so here you can see that we have this function hx and we have to find its derivative at 3, h prime of 3, and we have been given this information, all of these. Okay, so for this we will use some properties of derivative of functions. So what are those properties? These are called algebra of derivation. Okay, so if you have two function, let's say fx plus gx, which is just the addition of pointwise addition of two functions. So okay, so f plus g prime at some point a is same as plus g prime of a. Okay, so we are assuming that these functions are differentiable at a. Okay, so f and g are differentiable at x equal to a, and in that case this property holds. Okay, so even if you take the minus sign, f minus g of the derivative of f minus g, that is also the difference of the derivative in this way. Second property is if you have some real number, let's say for k in r, and you want to differentiate the function which is k times f at a, so constant multiples of f, then this is just k times the derivative. Okay, the third property we call it product rule. So product rule, that means we want to differentiate product of two function. Let's, this is called f prime g, fg because this is the product f times g, the pointwise multiplication, and we want to differentiate it at x equal to a. So its derivative is equal to the derivative of f at a into the functional value of g at a plus the derivative of g at a into f of a. Okay. The fourth property is called the quotient rule, and this quotient rule we have to apply in our current problem. What does it says? So for this, we'll assume that f of or g of x and g prime of a, these are never zero, and we are differentiating f by g at a, the derivative. Okay, so this is same as f prime at a times ga minus fa times g prime of a divided by g of a whole square. Okay, so this is called the algebra of differentiable functions or algebra of derivations, and the five properties, actually not the algebra, but still this is a property of derivative, and this is called chain rule. So what is the chain rule? Is this allow us to differentiate composition of two functions. Okay, so if you want to differentiate f compose g at a, that will be same as differentiating f at g of a and then multiplying the derivative of g at a. Okay. So these are some properties of the derivatives, and that we are going to use while solving the given problems. Okay, so notice that in this problem, so this h of x, the function, is just fx divided by 1 minus gx. uh, and we assume that gx is not equal to 1. Okay, so what is h prime of x? Okay, so just apply the quotient rule, and the quotient rule says that you have to differentiate the first function and multiply the second function and take the difference. That is, after taking difference, you have to multiply the first function with the derivative of the second function. So what is the derivative of second function? Second function means the function in the denominator, this one. Okay, so if you differentiate that, you will get g prime x with a plus sign, right? Because the minus of gx, and you have to divide by 1 minus gx to whole square. Okay, and therefore h prime of 3. Okay, so we have to find h prime of 3. It will be same as f prime of 3 in the bracket 1 minus g of 3 plus f of 3 into g prime of 3 and divided by 1 minus g of a whole square. Okay, now notice that all these values are already given. Okay, so you can see that we have been given f of 3, g of 3, f prime 3, and g of prime 3. So we'll use all these values. What is f prime 3 is 1 by 3. So f prime 3 is 1 by 3, 1 minus g of 3. So what is g of 3? It is 2. What is f of 3 is 3, and g prime 3 is 1 by 4. So the product is just 1 by 4, and then divide by 1 minus g of 3. So here is 3. Okay, so this is 1 minus 2 whole square. So 1 minus 2 is just minus 1, and you will take a square, you will get 1. This is just minus 1 by 3 plus 1 by 4, which is equal to minus 1 over 12. Okay, so if you find out, then you will get minus 1 over 12. So here the third option is correct. So minus 1 over 12 is the answer. Okay, so these are algebra of derivations or some rule. Okay, so now we'll just move to the next problem. Okay, so this equation is given x to power 1/3 plus y to power 1/3 is equal to 1, and we have to find the double derivative of y at minus 1. Okay, so again, so we will use this particular property of derivative, which just says that for r not equal to 1, if you want to differentiate dy dx of x to the power r, so this is dy dx, this means the derivative of the function with respect to x. Okay, so this derivative, this is just equal to r times x to the power r minus 1. Okay, so this property will be used here, and this is any real number. Okay, just not equal to 1. Okay, so r can be 1 also. So if r is 1, then yeah, so r can be 1. But if r is 0, okay, so this property holds for every real number, and that's how we differentiate it. Okay, and we have to find the y double derivative of y. So this is the equation: x to the power 1/3 plus y to the power 1/3 is equal to 1. So we will just differentiate this equation. Let's call it equation 1 with respect to x. Okay, so what do we have if we differentiate? So while differentiating, we will also use the rules of derivation, right? These are like sum of two functions, but this y it just depends on x. Okay, so y is the dependent variable and x is the independent variable. So if you differentiate this equation, you will get one third times x to the power one third minus one, right? This is the rule of differentiation for differentiating the powers. Plus now notice that this is like composition of two function. You are taking power of a function which is y, so you're composing two functions, right? Y is a function depending on x, and you are taking its power, so it's a power function and the function y of x. So that means you need to apply the chain rule. So in the chain rule is just first we'll differentiate this power function, and that will again give us 1 by 3 y to the power 1 by 3 minus 1, and then you will differentiate dy over dx. Okay, so basically differentiate y with respect to x. On the right hand side you will have 0 because 1 is the constant function. The derivative of constant function is always 0. Okay, so if you solve this equation, let's call it 2. Equation 2 gives us, or it implies that, okay, so implies that dy over dx is equal to, what you will do is just subtract, just simplify the equation 2 and you will get minus x to the power. Okay, what is one third minus 1? It is minus 2 third, right? Initially you get minus 2 third divided by y to the power minus 2 third. Okay, but in if you further simplify it, this is just y to the power 2 third divided by x to the power 2 third. Now we'll differentiate this third equation once more with respect to x, because we want to find a double derivative. This is just y prime of x. Okay, this is the first derivative. Let's differentiate it further. Okay, again differentiating with respect to x in equation 3. Okay, so what do we have? We have that y double prime of x is equal to, now notice that we are differentiating the third equation, which is the quotient of two functions. Okay, so this is a quotient of two functions, so we'll use the quotient rule of differentiation. Okay, so we'll differentiate the function with this negative sign. This can keep it outside, and if you differentiate the first function, you'll have 2 third of y to the power 2 third minus 1, which is minus 1 third into x to the power 2 third. Further difference and the differentiate the denominator, which is again 2 third x to the power minus 1 third into y to the power 2 third. Okay, so while differentiating this side, you are again differentiating the composite function. So that means there must be a dy over dx, right? Okay, and this divided by the square of the denominator, which is x to the power 4 by 3. Okay, so at the end, what do we have? So we also have to substitute this value of dy by dx from the equation 3 to the equation 4. You can call it equation 4. Okay, so from equation 3 and 4, we have that y double prime of x is equal to, okay, so this is minus 2 third y to the power of minus 1 third and x to the power minus 2/3, because you can see that here we have x to the power 2/3, in the denominator we have x to the power 4/3, so power gets subtracted. Okay, so you'll have x to the power minus 2/3 in the numerator and into dy by dx. And what is dy over dx? Is minus of y to the power 2/3. Okay, so minus will become plus. This is y to the power 2/3 and divided by x to the power 2/3, right? Okay, and then there was this minus sign, which will again minus minus will become plus if you open the bracket, and then you will have 2/3 y to the power 2/3 and x to the power. Okay, so minus 1/3 and minus 4/3, which is minus 5/3. So into x to the power minus 5/3. Okay, so if you again simplify it, then you will get that y double prime x is equal to, okay, so you can see that a lot of things can become common. Okay, first let's write out what is the final solution. Okay, so you can see that these powers of y, they will get just add up. So after adding powers of y, you will get y to the power 1/3 and x to the power minus 4/3 plus 2/3 into y to the power 2/3 and x to the power minus 5/3. Okay, take 2/3 common, y to the power 1/3 also comes outside, and x to the power minus 5/3 you can take outside. Okay, in the bracket you will have x to the power 1/3 plus y to the power 1/3. Now notice that this quantity inside it just equal to 1, right? We started from this equation. This equation was given to be equal to 1, and therefore the y double prime at x is just y to the power 1/3 into x to the power minus 5/3. Now we have to find this value at x equal to minus 1. Okay, but from this equation you can see that when x is minus 1, we have to find out what is y, because we also need the value of y to find this derivative, right? So let's find out. Okay, so at x equal to minus 1, what is 1/3 of minus 1? So this is equal to 1, and this will imply that y to the power 1/3 is equal to 1, and that will imply that y is equal to 1. Okay, so at x equal to minus 1, y is equal to 1. Okay, so you can write that at x equal to minus 1, we have y equal to 1. How? From equation 1. Okay, and therefore y double prime of minus 1 is just 2/3. Okay, so this is 1 to the power 1/3 into minus 1 to the power minus 5/3. Okay, so this is just equal to minus 2/3. Okay, so let me check if there is any mistake. I think my answer is not matching, so I have written that the correct option is the fourth one. So just let me check if minus 2/3 is the correct answer. Okay, so instead of finding the value of y at x equal to 1, we just from the third equation, if you just write it as x to the power 5 by 3, in the bracket it is just 1 minus x to the power 1/3, right? Now if you put x to the power minus 1, if you put x equal to minus 1, then what do you have? So I think this was not required. So this, there was a mistake, I think, in this statement. Okay, so from the first equation, you just substitute y to the power 1/3, which is just 1 minus x to the power 1/3. And now if you put x equal to minus 1, then you will have 2/3 of now minus 1 to the power 5 minus 5 over 3. It is just, okay, so 2/3 and minus 1. So this is just minus 1 into minus 1 and into 1 minus plus 1, right? Because minus 1 to the power 1/3 is just minus 1. So this is just turn out to be minus 4 over 3. So the correct option is the last option, the fourth option. And I think there is some problem. So what was the problem? So at x equal to minus 1, okay, so that was the problem. So this is the problem. If you put x equal to minus 1, then this on the right hand side, this will get added up. So this will just become 2. And now y is equal to 2 cube, which is 8. Okay, that's why we were having some problem. So y 1/3 is still equal to 2. So you can directly find out value from here also, that it is just minus 4 over 3. Okay. Okay, so it's time to move to our next problem. Okay, so in this fourth problem, a curve is given with this following equation: y is equal to x cube minus 4x plus 1, and this has smallest slope, and the slope is m at this point a comma b, and we have to find this sum a plus b plus m. What is that? Okay, so here we have to find the smallest slope at the point a comma b. Okay, and the slope we have to find, and the a and b that we have to find. Okay, uh, for finding the smallest slope, so what is the slope of equation at the point? Okay, so slope of the tangent, okay, tangent of the curve at a comma b. Okay, in okay no in general, okay, so what is the slope of the given curve is, okay, so it is given by the derivative at that point. Okay, so the slope is this y prime x, which is this 3x square minus 4. Okay, and we have to find the smallest slope. That means we have to find when y prime x is smallest. Okay, so y prime x is smallest or minimum if and only if x is equal to 0, right? Okay, so at x equal to 0, what is y? Y is equal to 1. Okay, so these are our point a comma b. Okay, so at 0 comma 1, the slope, that is y prime x, is minimum, and that minimum value, and the minimum value is equal to, so what is the minimum value? The slope is 3x square minus 4, but the smallest the slope achieved at x equal to 0. So the minimum value m is equal to minus 4, right? You have to put x equal to 0 in this equation. This equation we are minimizing. Now you can find a plus b plus m. Okay, so therefore a plus b plus m is equal to 0 plus 1 minus 4, which is minus 3. Okay, here the first option is correct. Okay, so the minimum value of the slope can also be found out using the derivative, right? We were okay, so we were finding the minima of this function, right? Y prime x, which was turned out to be 3x square minus 4. Okay, so okay, so the minima and maxima of a function always, if the function is differentiable, always occur at those points where derivative becomes 0. Okay, and we have to find the minima of this given equation. So we have to find its derivative and check where the derivative becomes 0. So what is derivative? Derivative is 6x. Okay, and this is 0 if and only if x equal to 0. So okay, so x equal to 0, this is a critical point. Okay, so this is like alternate solution. Okay, but these applications or the rules of finding minimum and maximum may not have been done yet. Okay, but there is no harm finding it here. Okay, so this x equal to 0 is a critical point, and we can see that at x equal to 0, the function takes the minimum value. At x equal to 0, y prime of x is minimum. Okay, so let's move to the next problem. Okay, so here two curves are given. So one curve is this, another curve. Okay, so two curves are given and they have a common tangent at point 1 comma 0. Okay, so for this common tangent, we have to find these relations between these unknown constant a comma b and a b c d. Okay, so because they have common tangent at x at 1 comma 0, so the common tangent means their slope of the tangent is same, right? So what is the slope of the tangent? The slope of the tangent is given by the derivative. Okay. So since both curve has same tangent, okay, let's call this curve y1 and this curve is y2. Okay. Since the both curves have common tangent at 1 comma 0, we have, okay, so x is 1 at 1 comma 0, x is equal to 1. That means y1 prime, the derivative at x equal to 1, must be equal to the derivative of y2 at x equal to 1, right? So this should hold. Now what is the derivative of y1 at x equal to 1? Okay, so you can find that the derivative of y1 is just 2x plus a, and the derivative of y2 is again 2x minus c. Okay, so this will imply that 2 plus a is same as 2 minus c. Okay, this will says that a plus c is 0. Okay, so this is the first equation of our relation, and for finding other relations we've just put 1 comma 0 this value in these curves y1 and y2. Okay, they also give us some relations, right? So at x equal to 1, y1 is 0. Okay, so this the tangents are common, but the point 1 comma 0 is also common. Okay, so this 1 comma 0 is a common point. Okay, so this situation is like this. So there is a one curve and there is a another curve like that. Okay, so maybe this is a very bad picture. Situation can be like this. Okay. So two curves have same tangent means at that particular point. So this is like point 1 comma 0. Both curve have the same tangent, right? This is the common tangent. The both curves are tangential. This is y1 and this is y2. So this is the situation. And since 1 comma 0 is a common tangent or common point, 1 comma 0 is, or the point 1 comma 0 lies on both curve y1 and y2. So this point must satisfy the equation of the both curve. So if you put x equal to 1, that means you will get y equal to 0. Okay, so if you put x equal to 1 in the first equation, then you will get a plus b is 0. And if you put x equal to 1 in the second equation, you will get d is equal to minus c. Okay. Okay, so if you put x equal to 1 on the first equation, then you will have 1 plus a plus b is 0. Okay, so 1 plus a plus b is 0. And if you put x equal to 1 in the second equation, you will have 1 minus c plus d is 0. Okay, so 1 minus c plus d is 0. Okay, so these are the relation we are getting, that 1 plus a plus b is 0. Okay, so notice that this a plus c equal to 0 will give this relations, that is c is equal to minus a, and b is and this particular relation will give b is equal to minus a minus 1, this relation. right? And the last thing, this equation gives that d is equal to c minus 1, right? Okay, so d is equal to, so this implies that d is equal to c minus 1, but c is also minus a, so this is just minus a minus 1. Okay, so everything is in terms of a, right? D is in terms of a, c is in terms of a, b is also in terms of a, and a is arbitrary. A can be anything, so these are all the relation between a, b, c, and d, so this third option is correct here. Okay, so let's move to the next problem. Okay, so here the curve is given in a parametric form. The parametric form means the okay, so both the coordinates of the curve, which are x comma y, they both depend on a single parameter. Okay, so this is the parameter t. So if t changes, x and y both changes. So the curve depends on t. The both coordinate of the curve x comma y, it depends on this parameter t, and you have to find the second derivative of y. That is, you have to find y double prime x at t equal to 3. Okay, so let's just find what is y prime x. So that will get, if you find dy over dt and dx over dt, right? Let's first find out what is dy over dt. You can see that both of these are given as a square root function. So square root means here x is just negative of 1 plus t to the power half, and y is just 3t to the power half. Okay, so again we will use the rules of differentiation, that is the chain rules and the derivative of power function. Okay, so this dy over dt is just half of 3t to the power minus half into 3, right? So this is 3 by 2 into 3t to the power minus half. And what is dx over dt? Again minus half, 1 plus t to the power minus half. Okay, so that's it. Okay, so after the applying chain rule, you'll get this thing. Okay, so now dy over dx. How do you get dy over dx? You can again apply chain rule, which is just say dy over dt into dt over dx. Okay, or in other word, it is same as dy over dt divided by dx over dt. Okay, why? Because dt over dx is just equal to 1 over dx over dt. Okay, so these are we are not treating them as rational functions. So these are not like numbers, dt and dx. They are not numbers. These are like operators acting on functions, and this is the relation between them function or these function, right? Because of the chain rule. This relation we are getting because of the chain rule. Okay, and therefore, what is dy over dx? So the dy over dx is equal to, you just have to divide these both of these things. So you will have minus 3 times 1 plus t to the power half divided by 3t to the power half. Okay. Now, so this is just y double prime x at in terms of t, and no, this is just y prime x. We have to find the second derivative. Okay, so what is the second derivative? We have to again differentiate this with respect to x. The second derivative is written at d square y over dx square, which is just basically differentiating again the derivative dy by dx with respect to x. Okay. Now, while differentiating these things with respect to x, we will use again the chain rule. Okay, chain rule, and here you have to also use the you need to use the quotient rule. Okay. Okay, so first let's use the quotient rule and simultaneously. So what we will do, we will just differentiate this thing with respect to t, and then we will differentiate t with respect to x, right? This is just same as differentiating d by dt of dy over dx. Okay, so differentiate this function with respect to t, and then differentiate t with respect to x. And by the previous lesson, this thing just becomes divided by dx over dt. Okay. Okay, so let's find out second derivative of y with respect to t. So what was dy over dx? We have minus 3, 1 plus t to the power half divided by 3 to the power half, right? Now we have to find d by dt of this function dy over dx, which we can easily calculate, right, using the quotient rule. So what does quotient rule says? It says that differentiate the first function or differentiate the function in the numerator, and if you differentiate that, you will have minus 3 into half 1 plus t to the power minus half, and then you multiply the function in the denominator and subtract and in the numerator you will have the square of, so just 3t. Now we have to just simplify this thing. You can see that we can take 3 by 2 common, right? So this is just minus half. Okay, take this 3 by 2 common, right? This half and 3, so we'll take 3 by 2 common, and let's take minus 3 also common, and in the denominator we'll have 3t, right? And the bracket will be left. The denominator we have 3t divided, and okay, so under root 3t divided by 1 plus under root 1 plus t minus 1 plus t under root divided by 3t. Okay, so this is just minus 1 over 2t, 3t minus 1 minus t divided by the square root of 3t bracket 3 plus 1. Okay. Okay, so now the y double prime x, which we have said that this is as d by dx of dy by dx, which is same as d by dt of dy over dx divided by dx by dt, and which is same as minus 1 over 2t 2t minus 1 divided by under root 3t into under root t plus 1, right? And now we are dividing by dx over dt. Now, so what was dx by dt? So this is our dx by dt, right? Let's write dx by dt. Dx by dt is minus 1 over twice of 1 plus t under root. So we are dividing this thing, whole thing by minus 1 over 2 under root 1 plus t. Okay, so this 2 and 2 just get cancel out. Minus 1 also cancels. Then 1 plus t under root, just they will also just cancel out with each other. And at the end, we are left out with 2t minus 1 divided by under root 3t. Now you can see that we have to evaluate y double prime x at t equal to 3. Okay. So at t equal to 3, y double prime of x is equal to 2 into 3 minus 1 divided by under root 9, which is just 3, which is 5 by 3. So I think there is again some mistake. So let me check this thing. Okay, so I think we are missing this t, right? This t is missing, I think. So 2t minus 1 divided by minus half is just cancelling root 3t, and we are missing this root t. Now if you put t equal to 3, then we'll have 3 root 3. So I think there is still some mistake. So I don't know where there's a mistake. I think there's some mistake. Some typo is there. Okay. So up to this point, everything is correct. And then minus 3 half 1 plus t power minus r 3 to the power minus half. So minus plus 3 by 2 minus 3 by 2 common. So this is not root t, this is just t. Okay, I don't know, maybe there's some problem with these options. There might be some typos, so I'll check it later and then I'll update it this on this PDF file. Okay, so because we are running out of time, so let's move to the next problem. So this is our next problem. Okay, so here this equation is given and we have to find out what is this. Okay, so this involves dy over dx. So basically first we have to find the derivative of y with respect to x. Okay, so what is the equation? The equation says that root x times y is equal to sec of 2x whole square. Okay, sec 2x whole square. Okay, so I think it is sec square x. Okay, so let's differentiate this equation both sides with respect to x. Okay, so apply the product rule here. So consider root x with respect to x, which will just give you half x to power minus half into y, and plus root x into dy over dx. And on the right hand side, apply the chain rule. First, because this is a power function, so we'll apply the rules of differentiating power function, which will just give us 2 times sec of 2x. Now we have to differentiate sec function. So what is the derivative of sec function? It is sec x tan x. So this is just sec square x and 2x into 2, right? Because we have to differentiate 2x also, and its derivative is 2. So into 2. Okay. So from here we'll have dy over dx. Okay, and we have to find out twice of cos of 2x square, right? So you can see that on the right hand side we have 4 times 1 over this is cos square 2x, And then, okay, so we'll just keep it like this, 10 2x. On the right hand side, we have half, and okay, so twice of under root x. Okay, so if you multiply both side like the denominator numerator by root x, then you'll have just x over root xy, right? Plus root x times dy by dx, and this is just equal to this particular thing. Okay. Now the root xy, this thing can be replaced by this thing from the first equation, which is the sec square 2x, and in particular that is the 1 over cos square x. Okay, so we have 1 over 2x cos square of 2x plus root x into dy over dx. Okay, so now from the first two equations, these two equations, what do we have? Because they are equal. Okay, so 1 and 2 imply that. So what we are doing, we are multiplying both sides by cos square 2x. Okay, so if you multiply both sides by cos square 2x, then you will have 1 over 2x plus root x cos square 2x into dy over dx, and on the right hand side we are left with 4 times tan 2x. Okay, so again this implies that because we were finding twice of cos 2x whole square, so what is twice of cos square 2x times dy by dx? So we'll just subtract this thing, minus 1 over 2x, and then we have to divide by root x and then multiply by 2. Okay, so this thing we have to sort it out. We have to simplify this. Okay, so we have 8 times x to the power half tan of 2x minus x to the power 3 third, right? Minus 3 by 2. Okay, so I think we are having again some mistakes. Oh, okay, you can see that this is we are subtracting minus 1 over 2x, so we have to also multiply by. Okay, so if you multiply this 2x here, you'll get 16x, right? So this is not x per half, this is 16x. Okay, because in the denominator we have root x also, so at the end you will have x power half. Okay, so 16 x to power half tan of 2x square. Okay, so we also forgot to write square. Okay, so derivative of sec x is sec x times tan square x, right? So that is the mistake. And that is why this second option is correct. Okay, let's move to this next problem. Okay, so we'll move to the next problem. So here you can see that the function is hx is equal to fx divided by 1 plus gx, and we have to find 12 times h prime of 1, right? For that we have to find the derivative of function hx, and for finding this derivative we will use the quotient rule, and the quotient rule says that you have to differentiate the first function, which is the denominator, which is the function on the numerator, and then multiply by the function in the denominator, subtract the function fx, and uh, subtract the product of the function in the numerator into the derivative in the denominator, which is minus of or plus of g prime x, right? And then you have to divide by the square of the numerator. Okay, and therefore what is s prime of 1? This is f prime 1 into 1 plus g of 1 minus f of 1 into g prime of 1 divided by 1 plus g of 1 whole square, right? And all these values are given. You can see that f of 1 is 3 and g of 1 is 5, f prime 1 is half, and g prime 1 is minus 4. So let's put all these values. So f prime 1 is half 1 plus g of 1, which is 5, minus f of 1, and then g prime of 1. So f of 1 is 3 and g prime of 1 is minus 4, which is plus 12, and again divided by 1 plus 5 whole square. Okay, so this is 5 plus 6 and into half, which is 3. So this is 3 plus 12 divided by the square of 6. Okay, now what is 12 times h prime of 1? This is 12 times 15 divided by 6 square, which is 36. This turns out to be 5. Okay, so the third option is correct here. Let's move to the next problem. Okay, so here you have to find those points on this curve where the slope of the tangent is minus 3 by 2. Okay, so always note that the slope of tangent is given by the y prime of x. So the y prime of x is the slope of tangent at the point x comma fx. Okay, so at x comma fx, which is just the y in this case because the function is fx is equal to y, so at x comma y. Okay, so y prime x is the slope, so we have to find the derivative of y. So what is y prime of x? So for that we have to differentiate the function, and if you differentiate you will get half minus, okay, you can see that. Okay, let me start over. And then okay, so notice that what is our function y of x? It is x by 2 plus 1 divided by 2x minus 4, and this we want to differentiate. Okay, so if you differentiate, if you want to differentiate this function, you have to differentiate these two functions individually and take their sum, right? So the what is the derivative of first function? This is just half. Okay, and what is, how do we find the derivative of the second function? This you can see, you can apply some rules, is that the derivative of 1 over x is just equal to minus 1 over x square. Okay, you can apply this property of the derivative. This property you can derive using the quotient rule, right? In the quotient rule you have seen that in the denominator you have the square of the denominator. Okay, and simultaneously applying this rule and the chain rule, you can find the derivative of the second part. And for finding that, this is just 2x minus 4 whole square let's okay, and multiply by the derivative of 2x minus 4, which is just 2. This is our derivative, half minus 2 divided by 2x minus 4 whole square. Okay, and we have to find now those values of x for which the slope is equal to minus 3 by 2, right? So let's equate this thing. 2 by 2x minus 4 whole square is equal to minus 3 by 2, and let's find out the value of x. Okay, so this is equal if and only if twice. Okay, so this is minus. So these are equal if and only if this is equal to half plus 3 by 2. So what is half plus 3 by 2? This is 4 by 2, which is just equal to 2, right? Okay, so this holds if and only if 2x minus 4 whole square is equal to 1. Okay, so this equation hold if and only if 2x minus 4 is equal to plus minus 1, right? If you that means there are two values. You will get two values of x. So this holds if and only if this is equal to 1 or 2x minus 4 is equal to minus 1. This first equation will give you x equal to 5 by 2. And the second equation will give you x equal to 3 by 2. Okay. Now for these values of x, you have to find the values of y, right? How can you find that? Because y of x is x by 2 plus 1 over 2x minus 4, right? So you can find y of 5 by 2. What is y of 5 by 2? You just replace x by 5 by 2. This is 5 by 4, 1 over twice into 5 by 2 minus 4, which is equal to 5 by 4 plus 1 over 1, right? This is just 1 plus 5 by 4, which is equal to 9 by 4. And what is y of 3 by 2? This is 3 by 4 plus 1 over twice into 3 by 2, right? Which is just 3 minus 4. So 3 by 4 minus 1, which is minus 1 by 4, okay? So what are those points where slope is minus 3 by 2? Those points are precisely x equal to 3 by 2 comma 1 by 4 and x equal to 5 by 2 and y is equal to 9 by 4. So add these points, this point and this point. The slope of the curve yx is minus 3 by 2, okay? So here this last option is correct. Okay, so let's move to the next problem. Okay, so here you have to find the value of c depending on some conditions. So what are those conditions? It says that if the line passing with these 2 points is tangent to the this curve, then what is the value of c? So there is a line and then there is a curve. Let's say this is curve and this is our line. Okay, and so okay, so this is our line and this is our curve y, and the line is tangent to the curve. Okay, so line is tangent to the curve at that point. So we have to find that point, or and okay, so how do we find that point? Okay, because the so since the line is tangent to the curve, slope of this line at this point of tangency equal to the slope of the curve at that point, right? So let's find the slope of the line. So slope of line joining, oh okay, it's joining 0 comma 3 and 5 minus 2 is, so what is the slope? The slope is just 3 plus 2 divided by 0 minus 5, right? This is just 5 divided by minus 5, which is minus 1. So what is the equation of this line? Let's find out equation also. Equation of line joining 0 comma 3 and 5 comma minus 2 is, this equation is y minus 3 is same as minus x, right? Let's imply that y must be 3 minus x. Okay, so let's check. If at x equal to 3, y is 3, at x equal to 5, y is minus 2, and what is the slope? It's minus 1. Okay, so this is the equation of line. Okay, and it's given that the slope, this line is tangent to that curve, so we have to find out where this line is tangent. Okay, so so what is the slope of the curve? Slope of curve yx at x comma y is given by y prime of x, right? That is the derivative of y. So what is the derivative of y? This y of x is equal to c over x plus 1. Just apply the standard rules of differentiation. You will get minus c over x plus 1 whole square, right? Now notice that at the point of tangent, this point which is common to both line y and line L and the curve y. Also, the slope at that point is equal to minus 1. Okay. Now, since slope is minus 1, we let's find out what do we get if we put the slope is equal to minus 1. So y prime of x equal to minus 1 if and only if, so minus c over x plus 1 whole square is equal to minus 1, which is if and only if c is equal to x plus 1 whole square. Okay, so at that particular point c must be equal to x plus 1 whole square. Okay, so we have to find that value of x. That means we have to find the point where the point is common to both line L and Y. Notice that if that point lie on the line L, then it must satisfy the equation of the line. But if it lie on the given curve, then it has to satisfy the equation of the curve. And therefore, the point of tangency which we want to find. So what is the point of tangency? The point of tangency gives that c over x plus 1 must be equal to 3 minus x, right? But you can see that c is equal to x plus 1 whole square. Since now this is equivalent to x plus 1 to be equal to 3 minus x, which is equivalent to 2x being equal to 2, and if and only if x equal to 1, right? And therefore c must be equal to 4, right? So fourth option is correct here. Okay, so let's move to the next problem. So if there are any doubts, then you can ask. You can just turn on your mic and you can directly speak. Right? Because I can't see your message on the chat box. Okay, so you can just unmute yourself and ask if you have any doubts. Okay, so in this, the last 11th problem, so it says that which of the following statements hold. Okay, so we have to find the slope of the curve at point 1 comma 1 and 1 comma minus 1, where the curve is given by this equation and the slope is given by y prime. Okay, the derivative of y at x comma y. Okay, so let's find out the slope. Okay, so slope of the curve yx at x comma y is given by y prime f x. Okay, so the derivative is the slope, and the equation of the curve is, so it is the equation of the curve. It is x cube plus y cube. You know, not x cube plus y cube, is x cube times y cube plus y square equal to x plus y. Okay, now we have to find the derivative of y. So just differentiate the equation both side. Differentiate, let's call this equation 1, both side with respect to x. We get, so if you differentiate, then we get, what do we get? So while differentiating, we have to also apply the rules of the derivative. Okay, so if we apply rules of the derivative, that means this is 3x square y cube plus 3y square x cube into dy by dx, which is the y prime x. Okay, so let's write it as y prime x plus 2y into again y prime x, which is same as the derivative of x, which is 1 plus y prime x. Okay, so from this we can find out, or we can extract the y prime of x. Okay, so taking y prime of x to be common, so what do we get? So only this term is free of y prime, right? So it's just minus 3x square y cube. Okay, so this term is also free of y prime. Let 1 minus 3x square y cube divided by 3y square x cube plus 2y minus 1. Okay, so this is the derivative of y, and now because we have to find slope at 1 comma 1 and 1 comma minus 1. Okay, so let's find out this slope. The slope is given by y prime x. So the slope at point 1 comma 1 is given by y prime of 1, right? So at x equal to 1, you have to find this slope. So that is y prime 1. And then we have to also find the slope at 1 comma minus 1. Okay, so just put 1 comma 1 in this equation. You will have 1 minus 3 divided by 3 plus 2 minus 1, which is equal to minus 2 divided by 4 minus, so minus 2 divided by 4. So this is equal to minus half. Okay, again, let's find the slope at point 1 comma minus 1. Okay, so at 1 comma minus 1, again, put y equal to minus 1 and x equal to 1, and you will get 1 minus. Okay, so because we are putting y equal to minus 1, you can see that if you take a cube, then you will have again minus 1. So this is just plus 1. So 1 plus 3. But you will see that in this case, the denominator becomes 0. Right? Why? Because this is just 3 and minus 2 minus 1. So you can see that the denominator becomes 0. So the slope is not defined. So this y prime. Okay, so let's not write it because the slope is not defined, right? It just becomes infinite. The slope at the point, this point is not defined because it becomes infinity. Okay, at other one, it is minus half. So at 1 comma 1, the slope is minus half. That's the first option is correct, right? At 1 comma 1, slope is minus half, and At other point 1 comma minus 1, the slope is not defined. Okay, so are there any doubts?
Hello, sir.
Okay, so if there are no doubts, let's move to the last problem of this live session. Okay, so this curve is given, but this curve is given in a parametric form. So the parametric form means the points of the curve, which are x comma y, the coordinates, they both depends on a other variable, the single variable t. Okay, this variable t, this is called a parameter, and you have to find the slope at t equal to 2. Okay, so basically you have to find,
Sir, here T is the parameter.
yes, t is the parameter on which both coordinate x comma y depends, and you have to find the slope, which is y prime of x at t equal to 2, right? This y as a function of t is just 1 minus 3 divided by t, and the x as a function of t is just 1 plus 1 over t square, and you have to find y prime of x, which is just dy over dx. Okay, so now using chain rule, you will get dy over dx is equal to dy by dt into dt by dx. Okay, but this dt by dx is just equal to 1 over dx over dt. Okay, so this identity that dt over dx is equal to 1 over dx over dt, this thing also you can drive using the chain relation, right? You just apply the chain relation on the identity function, because if you compose t with again x, then you will get the identity, and that identity function will give you that identity give you this equation. Okay, via chain rule. Okay, so therefore y prime of x, if you want to find out, then you have to divide dy over dt by dx over dt, and therefore we have to find out this the derivative of x and y with respect to t. Okay, so what is xt? So xt is 1 plus 1 over t square. What is its derivative? This is the derivative of 1 is just minus 1, and okay, so you can write it that as 1 plus t to the power minus 2. So derivative of 1 is 0, and t to the power minus 2, its derivative is minus 2 to 2 times t to the power minus 3, right? Applying the rules of power, the derivative of power functions. And then we have to find y prime of t. So this we can just write as y prime t divided by x prime t. So what is y prime t? So for that, let's recall yt, which is 1 minus 3 by t. 1 minus 3 by t. Okay. So y prime of t is equal to, okay, so again the derivative of constant function is 0, and then you'll have 3 over t square. So what is dy by dt or y prime x? So y prime of x, which is dy by dx, is equal to y prime t divided by x prime t, and that is equal to 3 times. So this you can write as 3 times t to the power minus 2, right? So 3 times t to the power minus 2 divided by minus 2 times t to the power minus 3. So at the end we'll have minus 3 by 2 times t. Now at t equal to 2, y prime of x is equal to minus 3 by 2 into 2, which is minus 3. So the slope at t equal to 2 of the curve. Okay, so we have just found out the slope. We have to also find out the equation of the tangent. Okay, so we have the slope of the curve. Now to find the equation of the tangent, we also need the point at which we are finding this tangent. So for that, you just put t equal to 2 in this equation of x and y to get the point. So at t equal to 2. Okay, so what is x? At t equal to 2, what is x? So okay, so because this is our x, 1 plus 1 over t square. So at t equal to 2, this is 1 plus 1 over 4, right? 1 plus 1 over 4, which is 5 by 4, and y is equal to, so what is y? Is 1 minus 3 divided by t, which is t equal to 2. 1 minus 3 by t. Okay, so this is minus half. Okay, so that means we have to find the equation of line. So equation of tangent at that point is basically the equation of the line that passing through what is, from where it's passed, x equal to 5 by 4 and y equal to minus half, with the slope. What is the slope? Slope is minus 3. With the slope minus 3 is, so how do I find the equation of this line? Okay, so this line is y minus half, which is plus half, that is equal to slope times x minus 5 by 4. Okay, so this is the equation of the line. Okay, so now we have to just simplify this. So if we simplify this, then we will get, okay, 2y plus 1 divided by 2 is same as minus 3 divided by 4. In the bracket, we'll have 4x minus 5, and then we'll have 2 times 2y plus 1 equal to minus 3 times 4x minus 5. So this is 4y plus 2, which is same as minus 12 times x plus 15. And this gives that the equation of line must be 12x plus 4y equal to 13. Okay, 12x plus 4y equal to 13. That means the first option is correct. Okay, so any questions? Okay, so this was our last problem. So at this point, we have finished solving all the problems of this live session. So thanks everyone for joining. If there are any questions, then you can ask. Okay, so if there are no questions, then we'll just end our live session at this point. Thanks everyone for joining. Okay, so let's meet on next week with a new set of the problems. That's all for now.